Hello ladies, gents, and everyones. It is Thursday, March 25th, and we're here to talk about this week's space and astronomy news. SN11, which is the next test flight of SpaceX's Starship vehicle, is maybe going to happen as soon as tomorrow. They successfully completed a static test fire on Monday, firing all three Raptor engines for about 2 seconds. There was some talk that it might happen earlier this week, but based on road closures in Texas, we're thinking no earlier than tomorrow, but hopefully very soon. Really excited to see how Starship is going to perform during this SN11 test. And speaking of tests, NASA's Space Launch System, or SLS, finally passed its green run test. So this was the test they tried to do back in January, but it cut off too soon, and so they decided to redo the test, but then there was an issue with the valve when they were trying to redo it in February, so they had to fix that. But they've just finally completed this successfully last Thursday. They fired the core stage for 8 minutes, and everything went off fine. This is the final step in all of the green run testing for SLS. And so the next step is that it's going to be refurbished after this testing and then shipped off to Kennedy Space Center, where it will be assembled with the booster and the other components for the Artemis 1 mission, which was supposed to be later this year, but we'll TBD if that's actually going to happen. But this is exciting news that SLS is finally passing this milestone. Ever since President Biden's inauguration in January, NASA has been being led by an acting administrator. However, President Biden just announced that he has his pick now for the new NASA administrator, and it is former Senator Bill Nelson. Nelson served in the House for 12 years and then in the Senate for 18 years representing Florida. He's been heavily involved in space policy, and he even flew on the space shuttle, and so he is a former astronaut. So he certainly has the credentials to be the new NASA administrator. However, some people are a little concerned because Nelson has in the past been very critical of private-public collaboration in the commercial industry and space, which a lot of people think is actually going to be the future, basically, of operating in space. So TBD how he's going to work with companies like SpaceX and that. And Nelson was also a really big proponent of SLS when he was in the Senate, which, although we did just get that good news about it, it has been plagued with a lot of issues, and it could be holding back some of NASA's missions. But overall, basically, it seems like Nelson's probably just going to be a continuation of current NASA policies, and so this doesn't really presage any big changes up at NASA, so just probably staying the course. Now that Nelson has been announced, he still needs to be confirmed by the Senate, but it's not anticipated that that is going to be an issue. The deputy administrator that will serve with Nelson has not yet been announced. Over in the physics world, there's some really exciting news that's coming out of the LHC, or the Large Hadron Collider. So basically, this is a device that smashes together particles in order to learn more about the particles that make up those particles. So it's really important for experimental particle physics. The Large Hadron Collider is probably best known for its detection and confirmation of the Higgs boson, a previously undetected particle. But other than that, it's been a little bit quiet on the front of detecting and kind of peering into these very smallest particles that make up everything. Now, all of these particles that are produced during these smashing events of hadrons in the LHC make up what we call the Standard Model. And the Standard Model is basically how physicists describe the basic forces and particles that make up the universe. And it has been in place for a long time, and it stood up to quite a lot of tests, and it predicted things like the Higgs boson, so it's a pretty robust model. However, some data from LHC experiments is now showing inconsistency with the Standard Model. That's exciting. In this case, there's a particular particle called a beauty quark. Don't ask. Anyway, this particle is supposed to decay into various subparticles, including electrons and muons. And scientists would expect, based on the Standard Model, that it would produce equal amounts of those electrons and muons. However, they have been detecting that it's actually producing more electrons than muons. So basically a result that is inconsistent with the predictions from the Standard Model. Now, the current level of significance of these results is what scientists call 3.1 sigma. So it's basically a way of quantifying the significance of a result, and so we want to be really, really certain, especially when you're doing something as groundbreaking as saying, no, the Standard Model is wrong. So in oversimplified terms, the 3.1 sigma roughly corresponds to about a 99.7% probability that this is not a spurious result. And that might sound like a lot, and it is, which is why they've published this paper that is going to be coming out in Nature Physics, and the preprint has been posted. But in particle physics, they generally use 5 sigma as a standard for considering it something to be detected. So at 3 sigma level, this is just evidence. This is evidence evidence for this potential new particle or force or interaction, but it's not considered official yet. But it's just a really tantalizing piece of evidence that is really exciting in showing that there's more to learn, there's more physics to be uncovered in these fundamental interactions. In the words of the paper's authors, if confirmed by future measurements, this indicates new physics beyond the standard model. So I think that's pretty cool. Now you might say, okay, this is cool and all, but we strayed a little far from astrophysics, but we really haven't actually, because these very fundamental interactions between particles and forces are actually hugely relevant to astrophysics, including the very early universe and cosmology and what's happening inside stars and everything like that. So these particle physics results could have really interesting applications in astrophysics. But in slightly less indirect, exciting astrophysics news, the Event Horizon Telescope has just released some really awesome new results. So if you'll remember, the EHT released back in 2019 the very first ever direct image of a black hole, and this was super exciting, still is. But the team didn't stop there. They've been hard at work at analyzing those results they got, and what they just have now released is basically that same image but now analyzed in polarized light. Basically means that they're getting hints about the magnetic field that's actually involved in the event horizon of a black hole directly, which is really, really cool. This is especially important in determining how black holes produce these really massive jets from their accreting material, which involves magnetic fields, and theorists aren't entirely sure how it happens. And so observational results like this are really the first time we get to test these kinds of models. And in this case, they found that only theoretical models that include highly magnetized gas near the event horizon were able to be consistent with these observations. Plus, it's just really cool looking. So yeah, this is really, really awesome work out of the Event Horizon Telescope collaboration. Really excited to see what else that they can do. If you don't know much about the Event Horizon Telescope, you should look into it because it's really cool. They basically use multiple different telescopes all over the world to create a huge, huge amount of collecting area and baseline for these observations of the very, very tiny things that are the event horizons of black holes. Well, that's all I have for you this week. Thanks so much for watching. I hope you'll come back again next week. Have a good one. Bye.